Hi, Sue, can you hear me?
We can hear you loud and clear.
Super. I'm having trouble loading up the slides for some reason.
So how long you been back in the US?
Just a day.
Just today. Well, it hasn't been today for too long in California.
Sue, are you there?
Yes. Yes, I'm here.
Good, thanks.
I'm here. I just think my Meetup is crashed. I can't get into the participants list. So we'll see what
Jeff?
happens.
Yeah, Jeff, are you there? Jeff, I can hear you.
I am here.
Super. I'm having trouble, Jeff, sharing slides for some reason.
Okay, we have it.
You just click share slides. That's all I've done. So let me end the share. I'm just clicking the share icon directly to the right of the join queue hand.
Yeah, it's not loading the right chair slides.
What browser are you using?
Firefox.
Same.
Seems to be the old slide decks. Even if I refresh them, it's not uploading the right slides.
They auto-loaded them and they pulled the list beforehand. If you changed the slides at the last minute, they could easily have auto-loaded the wrong slides. You need to then go in, delete the slide deck, add slide deck in the tool button and the tool icon, manage slides.
Yeah, the meeting materials is showing the right side of slide text. Reloading them. Let's see.
KU, do you want to try sharing your screen? If you have the slide deck in front of you.
Yeah, I could do that. Can you see them?
Yep.
All right, we should get started. Sue, Jeff, about 7 minutes late. Apologies. Welcome, folks, to IDR session 2 on the last day of IETF 13. Can you folks hear me well? This is Kayur.
We can.
Great.
Sounds good to me.
Can you hear me well? All right, super. Let's get started. We're about 7 minutes late. Apologies for that. Here is the note well. It says that if you're participating in IETF, you agree to follow the rules. Those of you who haven't seen this should pay special attention to the note well itself. Meeting tips, wanting to make sure how to sign into the session. Here is our pointers for that. Pointers to the random resources, which may be very useful to you, again, for the agenda as well as the preparations. And we have a full agenda today with lots of drafts. So we would like to make sure most of the questions that you may have, please take it on to the chat or on the mailing list. Yeah, here is the agenda. Any questions before we get started? All right. Shu Peng, I am just going to now switch to the preloaded slide screen.
Can you hear me?
Yes.
Good.
Shu
Okay.
Peng, go for it.
Yeah. Thank you, Chair. And this is Shu Ping. I'm going to present this APN flow spec. Next, please. Since we have presented a few times in this meeting, and we have a official wiki and without the APN active drafts, so you could refer to. So here, I skipped the introduction of the APN. And for the flow spec, we define a new flow spec component, APN ID. And here is we use the lens to indicate the mask and APN ID length. And we use the mask to indicate the base of the APN ID that needs to be matched. And here we gave an example. For example, the APN ID, there are two parts, and the group ID, APP group ID and user group ID. And in the mask, we have the base, which here you could see that it's actually indicates the parts of the APP group ID. And when it is matched, the APP group ID in the flow spec.
Shupang, we lost you. Shupang, are you there?
Yes, can you hear me now?
Yes, much better. Please continue.
Okay. Yes, so when it's matched, that means a successful match. And next, please. Yes, here we define 4 traffic filtering actions. And here I used figures, the diagrams to show the first one, the marking. Actually, this one can be used to mark the entire APN ID, which can be encapsulated in the packets. And here, the second one is used to match the mark to mark the partial parts of the APN ID, which is carried in the flow spec. And the third one is used for inherit the APN ID, which was carried in the original packets. And that means when you want to copy and encapsulate the APN ID in the outer tunnel header. And then for the third one, the fourth one is we use that for the staging. And that means you will get part of the APN ID from the original packets and then stage with the part of the APN ID in the flow spec. Next, please. And here, there are some, it's about the ordering and organizations of the flow spec for APN, because we found 2 things. One is that there is not only the flow spec rules for APN, and there are also other rules, so they will be coexisting. And the second is that the APN ID has different parts, and for each part that can be determined by different flow spec rules. So considering that, these 2 conditions, and here we define this 2 categories. One is subgroup ID, and the other one is a group ID. And for all the APN flow spec rules, we put it into one group and use the group ID to indicate that. And for others, we could put the rules into another groups. And for the subgroup, for each subgroup, we use it to contain the rules for a specific part of the APN ID. So here we also gave the usage principles. So within a subgroup, that is the same as what we have already defined. So this I won't repeat. And for between subgroups, that because each subgroup is ordered with ID, and if the evaluation in one subgroup stops or finish, it will start the evaluation in the following subgroup if there is any left. And between the group set, so the group is ordered with the group ID, and if at least one condition in this group is matched, and when the evaluation reach to the end, it won't continue. The evaluation will stop. Okay, so I think that is all. Next. Yeah, so do you have any questions or comments? Thank you.
Jeff, you have the mic.
Thanks for the presentation. 2 comments. First one is that this feature will require FlowSpec v2. We currently have no way to extend FlowSpec v1. Second comment is the ordering for your group and subgroup may need further discussion. There's going to be discussion of how rules are ordered in FlowSpec v2, and you'll want to make sure that you pay attention to that discussion. Thank you.
Yeah, sure. And I think this can be smoothly removed to the V2, but of course we can discuss about that.
Thank you so much. Thank you, Shupang.
Thank you.
The next one is Shunwan Zhang.
Yeah, can you hear me?
Yes, I can.
Oh, good. Thank you. Hi, everyone. I'm Sun Wang from Huawei. The topic that I am presenting is traffic steering using BGP flow spectrum with SRv6 policy. This is a work done by several vendors. Is under the organization of China Mobile. Next, please. Okay. This work has been presented at IETF 108 and 109 meetings, and we got a few good feedback from the IETF community. Thanks to everyone for their useful comments and suggestions. At this point, all the comments have been addressed. Thanks for John and Jeff's comment. Now the intent state has been changed to informational. Although it's informational, the specification described in this document is very useful. It can help unify the implementation across multi-vendors. The most important update is that we have added a section to report multi-implementations. Next, please. We have introduced the detailed solution twice in the past presentations. And here are some summary information. Our basic idea is to reuse the components from multi-standard documents. Based on past comments, we add some more clear description here. They are also described in the drafts. Number one, at the current stage, this work discusses how to use FlowSpec to match the global routing table prefix. Number two, we only support the usage of one redirect IP community and one color community. How to support the multi-extended community attribute will be discussed in the other drafts. Next, please. Oh, no. Number three, both the intro AS and the inter AS use case are supported. Number four, regarding the usage of prefix attribute component, we have two options. If the last SRv6 SID in the segment list is USD flavored, then we can use option 2. Both two options have already been supported by multi-vendors. Next, please. Okay, this work has been implemented by multi-vendors, and the multi-implementations had a good interoperability test, which is hosted by China Mobile. The following table shows the participating vendors and the device that pass the test. Thanks to China Mobile for putting multi-vendors into a perfect team. Thanks to all the vendors who contributed to this work. Next, please. Okay. Next date, we will update the implementation report to the IDR wiki, and all the known comments has been addressed. We request WG adopt this work. And any question or comments are welcomed. That's all. Thank you for your attention to this work.
Yes, Yi Song, you have the mic, please.
Me?
Yi Song, okay, perfect.
Okay.
Thank you.
Okay. I'm Yi Song Liu from the China Mobile, and I want to say that currently there is a lot of public network traffic in China Mobile network, and as an operator, I think it is very useful to optimize the traffic by using the BGP flow spec with the SRE6 policy, and we have completed the lab interop test with multiple vendors, as Shunwan mentioned, and so I think it is also valuable for the working group. Thank you.
Thank you.
Thank you so much.
Oh, thank you, Kiel.
Wim, you have a mic? You have any question?
Wim Hendricks, yeah, I'll post a draft, but there is a draft already in IDR that does something similar. So I will post it in the as an email, but I think we should look to see whether we can have synergies between that proposal already, because that's already has progressed quite a bit already. Okay.
Okay. Thank you.
Thank you.
Next on the agenda is BGP flow specifications for DetNet flow mapping. One.
Ciao, can you hear me?
Yes, I can hear you well. Please continue.
Okay, thank you. I'm Chuan Xiu from ZTE. This is a BGP flow specification for the net flow mapping. Next slide, please. First, let's look at the update from last version. We have presented at IETF113 and got feedback from DetNet and the IDR working group. They are very appreciated. First, we got comments from the chair. It is required to clarify that this document is focused on TSN mapping, not generic DetNet. And second, the DetNet chairs are okay to work on this topic in either DetNet or IDR. And we also got comments from Jeffrey. It needs to be implemented in flow spec version 2. So based on the comments, we changed the draft name to clarify the TSN mapping. It is now is the BGP flow specification for DetNet and the TSN flow mapping. We also changed the extensions from BGP-FS version 1 to BGP-FS version 2 as per the as divided in draft health IDR flow spec version 2. We added the TSN sub-TRV in BGP-FS version 2 L2 header TRV. We also add the sequence action sub-TRV in BGP-FS version 2 wide community. we added data sub-TLV in Pgprs version 2 in IP header TLV. Finally, we add TSN action sub-TLV in Pgprs version 2 wide community. Next slide, please. So this is the overview with TSN and DataNet mapping. Dividing RFC 8655, the DataNet might provide the deterministic service for the TSN and the system, and the DataNet IP and the MPLS flows may be carried over TSN subnetworks. So the primary requirements of the controller plane for the TSN and DataNet flow mapping is as follows. The mapping between TSN streams and DataNet flows is required for the service proxy function at DataNet engine nodes, and the mapping table can be configured and maintained in the control plane. So this document proposes the extensions to Pgprs version 2 for TSN and DataNet mapping by using the traffic filtering rules to identify the packet and using the associated action to map the packet to the related service. So next slide, please. So we first proposed the Pgprs extensions for TSN stream mapping to DataNet flow. For the filtering rules for TSN streams, there are a string ID is a 64-bit field that identifies a string in TSN, and the string identification functions are defined in HVE. And there are other parameters has been defined in IDR flow spec L2 VPN. And so this document proposed a new TSN sub-TLV in L2 head TLV to identify the TSN string ID. We just propose the mask and the match string identification for TSN traffic filtering. And for traffic action, for TSN streams, the action is to accept the TSN streams that matches the rule and map the streams to the DataNet flows. So the action for L3 traffic with extended communities has defined mailing parameters in the BGP flow spec label draft. So this document proposed the sequence action sub-TLV in Pgprs version 2 wide community. Next slide, please. So for the DataNet flow mapping to TSN string in Pgprs extension, for filtering rules for DataNet flows, the L3 traffic strings have defined and can be used for DataNet IP flow. For example, the S label in DataNet MPLS flow can use the filtering rule defined in draft IETF IDR flow spec MPLS batch. So this document proposed a DataNet sub-TLV in Pgprs version 2 in IP header TLV. We just defined the DCW in for the DataNet MPLS flows. For the traffic action for DataNet flows, the extended action for an DataNet traffic filtering is to accept the DataNet flows that matches the rule and map the flows to the TSN strings. So this document proposes the TSN action sub-TLV in Pgprs version 2 wide community. The TSN provide can be defined to converted to the string related parameters. For example, the TSN string ID, string handle, sequence number, and the traffic scheduling information. Next slide, please. So this is what the extension for Pgprs version 2. Next step we would like to discuss and collaborate with Pgprs version 2 and the draft health IDR flow stack version 2. So comments and discussions are very welcome. Thank you.
Any questions? Suzong, please go ahead. Thank you.
Hi. Can you hear me well?
Yes.
Oh, thank you. This is Xuesong from Huawei. One question for the six number, because in the net six number is used for the merge the redundancy flows. So I'm not quite understand why we use six number as the filter of a TSN flow. Maybe more explanation or descriptions could be ended here.
Yeah, thank you for your comments. We will add the description in next version. Thank you.
Thank you so much. So the next topic on the for the discussion is the BGP autoconfig discussions. Jeff and Sue, do you want to take a lead on that? Jeff?
Yes, I'm here. I don't recall that being as part of our core agenda, but certainly there should have been sure slides to go with it if so.
Okay, perfect. Then we'll continue.
Here.
Next on the list is then, in that case, LSD extensions for SR policy extensions for the matrix G.
Yeah, I think the next one is as a policy, flow spec for the load balancing group on the agenda. Or do you want to shift them?
It's not appearing on the list.
Yeah, this one.
Perfect.
Hear me?
Yes, I can hear you. Please go ahead.
Thank you. Hello, everyone. And this is Wu Zhuyin from Huawei. Today, I'm going to talk about the flow spec redirect load balancing group community. Next slide, please. First, let me explain the motivation and make a statement of our problem. As we know, P2P flow spec specification load flow rules that carry traffic policies to steer traffic. In some scenarios, to steer traffic to balancing group, either in close multipath or on low-cost multipath. As shown initially for the 50 bit traffic to router 1 from router 0. We may want to steer traffic to router 2, router 3, and router 4 in a ratio of 1 to 2 to 2. And then if the controller supports detecting the network, the ratio could be changing according to network running status. And the routers may be deployed in IP, MPLS, or SRv6 networks. So we expected to support all types. Also, in some implementations, ECMP of redirect to IP action can be achieved by encoding multiple redirect extended communities. The current set of mechanisms can hardly support ECMP of SRv6 tunnels, nor UCMP of other types. Next slide, please. To achieve this, we propose the redirect load balancing group community. It is an external to Pgp community container attribute defined in the WebBGP community's draft. It allows traffic direction to a load balancing group and supports both ECMP and UCMP scenarios. As the picture shows, the general format complies with BGP community container attribute. For example, the fields of the type flags, reserved, length, community value, source AS number, and context AS number comply with the corresponding definition. In BGP community container attribute, we define a new community value representing the redirect load balancing group community type. The value is to be defined. And subtype is 3, representing BGP wide community parameter TLV defined in wide BGP community's draft. And the parameter TLV must present and should appear only once in a redirect load balancing group community. Parameter TLV contains a list of atoms. Each represents a specific redirection action. Next slide, please. Atoms are encoded as TLVs, which comply with wide community atom format, and we define some atom defines of atom formats. The figure is one of formats. It's IPv6 prefix with color and weight, indicating the direction path is weighted and to a SRv6 tunnel. It contains the fields of the type, length, flag, IPv6, color, and weight. The type is used exclusively within redirect load balancing group community, and the type value is 8. The length is fixed for each atom. The flag is to architects reserved for future use must be set to 0. The IP video is IP video address or SRv6 tunnel endpoint for redirection. The color is SRv6 tunnel color for redirection. The weight is the load balancing weight. Next slide, please. Currently, we have introduced 8 types actions for both IPv4 and IPv6 nest. Cover the prefix only, prefix with weight, prefix and color, prefix and color with weight. In principle, sub-TLVs may be combined in any mode. The supported combinations depend on the specific implementations. the redirect globe community contains more than one atoms. If not all atoms are of a weighted type, these atoms will form a ECMP group. If all atoms are of a weighted type, these atoms will form a UCMP group. In this case, the weight field value of these atoms should be ignored, and the values are used as the ratio of the UCMP group. Next slide, please. Welcome more comments and discussion. Thank you.
Jeff, you have the mic.
Thank you for your presentation. A couple of things. First thing, we will ask the authors for wide communities to review your extensions for the atoms and offer some advice. As an example, it's unclear whether we need a new atom for color. Integer could work in that spot as an example, but that's a small detail. The second item I would ask you to consider in your draft is as FlowSpec v2 begins its work and is starting to look at how to do load balancing and potentially interactions of different actions, we need to figure out how this feature is intended to behave if you have more than one type of redirect community present. It may just simply be an error case. It would be good if you discuss that in your document. Thank you.
Super. Thanks, Sue. You have the mic.
One
Sue?
slide. Oh, can you hear me, Care?
Yes. Yes, please go ahead.
Okay. Will, would you go back one slide, or Care, would you go back one slide? 2 slides, I think. One thing I didn't understand in your discussion is what, please go one more slide down, Karen. I'll see if I can help.
This one?
Okay. No, but I'll just number 5, please. That'll help you. The question is, you had a discussion for waiting on these. It would be good to discuss not only if you can handle one, as Jeff said, or one other. There are other ones, and then I'd like you to improve the text on waiting. And I think I'll just leave it at that. Karen, you can go on. I'm glad to chat with you offline on this one. Jeff is correct on the wide communities. I have questions specifically on how you're weighting this compared to other things in the V2 spec. So we'll go from there later.
Super. Thank you so much, Wu.
Okay.
Thank you.
Thank you.
Thank you.
All right, G, you're next.
Okay. Can you hear me?
Yes, I can.
Okay. Hello, everyone. This is Jidong from Huawei. I'm going to give an update about this draft called Pgprs Extensions for the Scalable SR-based enhanced VPN. Okay, next page, please. First, some background about this work. We have the VPN framework in the TIS working group, which is described the framework for the enhanced VPN services. And one of the typical use cases is to deliver the IETF network slice service. And IETF network slice framework is also described in TIS. That document introduced a concept called NRP, network resource partition, for the network slice realization. And in the context of network slicing, NRP is considered as an instantiation of the VTN defined in the VPN Plus framework. Considering the scalability of the NRP is important, we have another draft in the TS working group, which is working on the analysis and the optimization considerations of the scalability of NRP in both the control plane and the data plane. It also provides some guidelines for the protocol extensions. And for the IGP extensions to provide a scalable SR-based VPN Plus service, there's a draft in the LSR working group. So here in the IDR, we would like to introduce the Pgprs extensions for the scalable SR-based VPN Plus. This document introduces mechanisms to distribute the intra-domain and the inter-domain NRP topology and the resource attributes to the network controller. Okay, next page. Yeah, here we would like to give an overview of the related documents in several working groups. As I just mentioned, the framework documents are in TS working group, which includes the IETF network slice document. It is working on the concept and the general framework. And the VPN Plus framework provides a mechanism which can be used for the slice realization. The NRP scalability considerations is also in the TS working group. Then for the data plane, there are several data plane encapsulations mechanisms to carry the NRP or VTN specific information. The first approach is described in the Spring working group based on the resource-aware segments. And in the IPv6 based encapsulation, there's another draft based using the IPv6 hop-by-hop extension headers to carry the VTN ID, or we can call it an NRP ID maybe. There's also another draft in the MPRS working group to provide a similar functionality. For the control plane, we have several set of drafts for the control plane and to distribute the VTN or NRP information, both in the network domains and to the network controllers. And this document is just one of this set. It provides a scalable VTN or NRP information distribution. We also have the drafts working on the NRP or VTN specific path computation and instantiation based on the BGP SR policy or PSAP protocol. Then in the management plane, there's young data models to provide the network slice service model to the network slice customers, and also an NRP model for the instantiation of the NRP in the network. Okay, next page. So some information about the optimization introduced in this document. The first is to improve the scalability. The practical mechanism is to map multiple overlay connectivity services to one shared VTN or NRP, so that the NRP provides the underlying network topology and the resources required by a group of the services. And the second approach is that we can decouple the resource attribute of the NRP so that multiple NRPs can share the same topology, and also they can share the topology specific route computation. We can also allow multiple NRPs to share the same set of resources on some of the network segments to allow flexible resource isolation or sharing based on the requirements. The last point is to introduce a network-wide data plane identifier in the packet so that we can avoid to introduce additional per NRP SRCs or SRA6 locators in the network. So we will talk about the Pgprs extension to achieve these optimizations in the following slides. Okay, next page, please. So here is the first extension. We introduced the NRP definition sub-TRV in the maybe we'll call it TRV in the Pgprs attribute, which is associated with the node NRI. It is used to advertise the relationship between the NRP and the associated topology and algorithms and other attributes. Here, this TRV contains 32-bit network-wide identifier of the NRP, and there's a MTID field to carry the topology ID associated with the NRP, and another 8-bit algorithm ID field, which can be either a normal algorithm or the flexible algorithm. It also introduced a sub-TLVs for the future extension for optional attributes associated with NRP. Okay, next slide. The second extension is to introduce an NRP ID sub-TLV, which is used to describe the list of NRPs that a link belongs to. And this can be carried in the Pgprs attribute, which is associated with a link NRI. It can be used for both the intradomain links and also the interdomain links. So the format of the TLV is shown here. It basically contains a list of the NRP IDs and the flag field and the reserve field. It also can be used as a sub-TLV for the layer 2 bundle member attribute TLV. We will talk about this in the following slides. Okay, next page. The third extension introduced is to have a link attribute flags TLV. It is used to specify the attributes of a link, and it can be carried in the Pgprs attribute associated with a link NRI or as a sub-TLV in the L2 bundle member attributes TLV. And the format of this TLV is consistent with the flag fields defined in the ISIS link attribute sub-TLV. And here we introduce a new flag called E flag. So it is used to indicate whether the link can be used for load balancing across a bundle or the group of links, or it is can only be used exclusively for the traffic associated with a specific set of NRPs. Okay, next page. So for the topology information distribution, here for the intradomain topology advertisement, we will reuse the existing multi-topology and flux algo-based mechanisms, and multiple NRPs can associate with the same topology algorithm tuple to avoid the duplicated topology information distribution in the network. Here, the multi-topology is used to define the logical topology and the topology link node attributes, and flux algo can be used to specify the metric type and the topological constraints which apply to topology. And with the extension for S-segment routing, we can also distribute the protopology algorithm SRCs and the SRv6 locators using Pgprs. Okay, next page.
G, are you still around? I can hear you.
Can you hear me?
Yes, I can hear you now.
Okay, so we are on this page, interdomain topology. Okay, so for the interdomain topology information advertisement, we will reuse the Pgprs EPE to distribute the interdomain link connectivity and also the BGP peering segments, including the peer adjacency seed, peer node seed, and the peer set seeds. And here, we will also need to use the NRP IDs TLV in the Pgprs attribute of the interdomain link NRI, so that we can describe the list of NRIs, the NRPs the interdomain link is associated with. Okay, next slide, please. Okay, for the resource attribute advertisement for each NRP, we have considered two options. the first option is to use a L2 bundle-based approach, so that we consider each partition of the link resource as a physical or virtual L2 bundle member link of the layer 3 link, so that we can use the Pgprs extensions for the L2 bundle member links to advertise the bandwidth and other T attributes of this partition, link resource partition. And to associate this L2 member link with the NRPs, we also use the NRP ID sub TLV with this Pgprs L2 bundle member attribute TLV. Here we also use the link attribute flags as an E flag defined in this document to indicate whether this bundle member link can be used for load balancing or it is exclusively for the NRP's usage. And for the T attributes information like the bandwidth and other T attributes of the L2 bundle member link, this can be advertised by reusing the existing T attributes of the Pgprs. Okay, next page. Thanks. The second option is we can use the per NRP link T attributes to advertise the different partition of the resources allocated to the different NRPs on the link, so that this per NRP specific T attribute TLV is defined, which contains a list of the NRP IDs and the list of the T attributes which are shared by the set of the NRPs on this specific link. Okay, next slide, please. Okay, this in addition to the advertisement of the topology and the resource attribute, we also need to advertise the NRP specific data plane IDs so that we can generate the forwarding entries for different NRPs. Here are also two options. The first one is we can use per NRP SRCs or SRv6 locators, and this, following this way, we need to add a set of new TLV or sub TLVs for the advertisement of the NRP specific MPRS seed or NRP specific SRv6 locators and seeds. The second option is we use the mechanism, the optimization mechanism mentioned in the beginning. We use dedicated NRP IDs in the data plane so that we can use the same ID in the data plane as the one in the control plane. This way, we don't need to advertise additional NRP-specific IDs for the data plane, and this can save the control plane resources for the additional ID distribution. And in this mechanism, need to introduce the new encapsulations in the packet, and the encapsulations for IPv6 and MPRS are described in the separate drafts in the IP6man and the MPRS working group. Okay, next slide. Okay, so for this document, we would like to hear comments and feedbacks about this approaches and the options described, so that we can refine the document in next revision. And by the way, we would like to mention that we are working on the terminology alignment with the TIS documents and other IGP extension drafts like the FVT and NRP. We will align them in the next version. Thank you. Comments?
Thank you, G.
Okay, thank you.
Thank you. Next we have is Giuseppe who's going to talk about SR policy extensions for IFIC. Giuseppe, can you hear me?
Yeah. Hello, everybody. Can you hear me?
Yep. Please go ahead.
Yeah, this is an update about the BGPSR policy extension for IFIC. So next slide. Yeah, just a quick background. So IFIT denotes all the on-path telemetry techniques, so in particular in situ AM and alternate marking. We all know that an head-end can be informed about the candidate path for an SR policy by using BGP, and there is a well-advanced document on that. So this draft simply extends this document and extend BGP to distribute SR policy carrying also the IFIT information. In this way, IOM and alternate marking can be enabled automatically when the SR policy is activated. Next slide. Yeah, this is basically the extension. So how the IFIT attributes are included in the BGP as a BGP extension. So at candidate path level, the IFIT attributes are attached as sub-TLVs. Since the SR policy candidate path is encoded in the tunnel encapsulation attribute, it is simply extends the attributes defined in the IETF IDR segment routing T policy draft. So as I said, there are 5 sub-TLVs currently defined, 4 for in situ OM and 1 for alternate marking. Next slide. Next slide, I guess there are the details of the sub-TLVs. Of course, they are aligned with the relevant document for in situ OM and alternate marking. Next slide. Yeah, in this slide, we just explain how this document complements the SR policy operation described in the segment routing T policy draft. So the only addition is that after the head-end can be informed about multiple candidate paths via BGP or PSEP, additional information like IFIT are included at candidate path level, and then the selection of the best candidate path can be done and selected and installed into the forwarding plane. It may be possible for an implementation to choose the candidate path also considering the supported IFIT attributes based on the local configuration. And then the IFIT methods in situ AM and or alternate marking can be enabled automatically. Next slide. Okay, yeah, we consider this document quite relevant to enable in situ AM and alternate marking for control mechanisms. As also mentioned before, it is a simple extension of the current draft on segment routing T policy. Yeah, of course, we welcome questions and comments on this. Thank you.
Thank you so much. Any questions? Cool. Thank you.
Okay, thank you.
Next on the presentation, we have SID algorithm information in BGP by Yao.
Hi everyone, this is Yao Liu from ZTE, and the presentation is about advertising set algorithm information in BGP. Next slide, please. As introduced in the draft segment routing T policy, 11 segment types, segment sub-TLVs from type A to type K are defined to encode SRMPS or SRv6 segments, and SR algorithm can be optionally specified in segment sub-TLVs for SRMPS prefix, SRv6 prefix, and SRv6 adjacency. And this document defines some new segment subtier-Vs with algorithm to meet more requirements when delivering SR policy via BGP. Next slide. One kind of new segment subtier-V is SRMPRS adjacency with optional algorithm. The draft IETF LSR algorithm-related adjacency set complements that besides prefix set, the algorithm can also be included as a part of a SRMPRS adjacency set advertisement in scenarios where multiple algorithms share the same link resource. So in this case, an SRMPRS policy advertised to the head may also contain algorithm-specific adjacency. Following are the four new segment subtier-Vs. The formats are similar as the existing type E, F, G, and H, except that there's an optional algorithm field with them. Next slide. So I'm gonna skip the detailed structure of the new segment subtier-Vs. Next, please. And another new kind of segment subtier-V is seed only with optional algorithm. Carrying the algorithm information along with the seeds can be used for verification purpose. The header can check if the seed value and the related algorithm received can whether it can be found in its SRDB if requested to do so. And the header may also needs to know about the seed-related algorithm for troubleshooting and network management purposes. So type L and type N are defined separately in this draft for SRMPLC set and SRV6 set. The format are similar to type A and type B segment subtier-V, except that there's an optional algorithm field. Next slide. Yeah, that's all. And we welcome feedbacks and comments. Thank you.
Thank you so much. Ketan, you have a mic?
Thanks for the Ketan Talaulikar. Thanks for the presentation. I think a couple of those seems valid or new. Where adjacency said was, for adjacency said we introduce algorithms. I'm not sure about the other ones, but in any case, it would be good to get some review or feedback from Spring Working Group. Thank you.
Oh, sure. Thank you.
Any other questions for y'all? Thank you so much, y'all.
Thank you.
Next presentation we have is on BGP policy extensions for metric. This is Ka Zhang. Ka, you have a mic?
Hello, can you hear me?
Yes.
Okay, thank you. My topic is BGP policy extension for metric. I'm Ka Zhang from Huawei. Next slide, please. As BGP can be used to propagate the SR policy candidate paths to the head-end nodes in the network, and using BGP, the SR policy SAFI can be encoded like this, and with the key distinguish policy color and endpoint, and each candidate path can have several segment lists. Next slide, please. By using BGP as a policy, NLRI controllers may deliver different SI policies which satisfy the constraints of VPNs or BGP routers. But sometimes the BGP router or VPN router need to choose the next hop according to the IGP metric of each SI policy. For example, in this scenario, on PE1, the router prefix C2 has two different next hop. One next hop is P3, the other next hop is P4, and each next hop has one SI policy, SI policy 1 and SI policy 2. Both SI policies satisfy the delay and the bandwidth constraints, and the IGP metric of active path of SI policy 1, which is P1 to P1 to P3. The IGP metric is 20, and whereas the IGP metric of the active path of SI policy 2, which is P1 to P2 to P2 and to P4, the IGP metric is 120. In this case, if P1 wants to choose the next hop according to the IGP metric of SI policies, thus need to know the active IGP metric of the SI policy. Thus, the controller should deliver the IGP metric of SI policies using BGP SI policy protocol. Next slide, please. To solve this problem, we propose to add the metric subTLV to BGP SI policy protocol. The metric subTLV is added as an subTLV of segment list. Next slide, please. And the format of metric subTLV is defined as follows. Here the type metric is to be defined. The length is 6, and the metric type specifies the metric type. Now we can define several values. For example, IGP metric, T metric, hop counts, delay metric, or loss rate metric. And the metric value is encoded in 32 bits in IETF floating point format. Next slide, please. And by using the IGP metric of SI policies, the controller can deliver the IGP metric of different SI policies, and then on PE1 we can get two different SI policies, and the IGP metric is different. Thus, PE1 can choose the next hop according to IGP metric, and then the results, the routing choosing result is next hop is P3. Next slide, please. When SI policy head end get the SI policy segment list with metric, how to process the metric is the local policy. For example, the active candidate path of SI policy may have several segment lists. Each segment list have different metric. It is recommended that the segment lists in one candidate path have the same metric type. And if the metric values of segment lists in one candidate path are different, the candidate path metric can use the minimum value as the metric of the candidate path. And the SI policy use the metric value of the active candidate path. The SI policy metric value then can be used in routing preference. Next slide, please. And that's all. Welcome questions and comments. Thank you.
Any questions for Carl? Lou, please go ahead. You have a mic.
What's the consideration about the interdomain while your SR policy is across multiple IGP domains? Because your extension is about IGP metric. What's the interdomains manual?
Okay, different because the different SI policy paths may also satisfy the delay or bandwidth of the application, and so the application may want to IGP metric to choose the different hop. Thus, we need to know the IGP metric of the path of SI policies.
So if the SR policy is across multiple IGP domains, is this scenario out of scope or have other considerations?
Okay, then the controller may control different areas of IGP. Then the controller can know the IGP metric of the whole path. So the controller can download the IGP metric to the device.
Okay, let's take it to the list. Thank you.
Thank you. Actually, I got a question for you. You have defined different matrix. Do you also have to define another matrix type for AIGP, or AIGP is not applicable here?
Okay, maybe we can add it to the metric type. The metric type can be extended.
Okay, super, super. You may want to consider that.
Yeah, okay.
Thank you.
Thank you very much.
The next presentation we have is BGP for beer TE path. This is going to be presented by Haimo.
Yes.
Please go ahead.
Hello, everyone. Today I'm going to talk about the BGP for BATE path. Next page. So I would like to thank Jeffrey Zhang, Susan, and Tony P for their valuable comments and suggestions. So according to their suggestions, we made some updates. These updates to the previous version include selecting tunnel type for BATE path under tunnel in-cap attribute and making some editorial changes. Next page. Under tunnel in-cap attribute type 23, we define tunnel encapsulation TLV for BATE path. This TLV contains some sub-TLVs. This sub-TLV includes BATE path sub-TLV, BATE path name sub-TLV, and path identifier sub-TLV. BATE path sub-TLV encodes an explicit BATE path. BATE name path name sub-TLV consists of the name of the BATE path. Path ID sub-TLV contains subdomain ID, BFR ID of the ingress of the BATE path, and the tunnel ID and the path number. Next page. So I think after the updates, the draft is clear and simple, and we will still welcome comments and would like to request for adoption.
Are we taking questions, comments? Can they still hear us?
Why don't you go ahead?
Okay, Jeffrey Zhang from Juniper. We probably don't need to call it as beer TE, just call it beer. Then whether it's a beer TE or not, it does not really matter. Probably just call it beer.
Yeah. Yeah, that's okay. That's okay. Yeah, there's no problem for me. Thank you.
All right, Sue, you're next.
Just so you know, Waymo, your draft is in the queue for adoption. I have a favor to ask. Do you think you could ask the bidder chairs to summarize their work in this area and send it to us, or shall I do that? It's good. I think as part of the pre-adoption cycle, we need to have an understanding of is this conflict, is this something the beer working group is thought of, worked on? Is it something I think we should pick up? That would be helpful. Did you do that a couple sessions ago and I'm forgetting it?
Oh, you mean request the chair of beer to have a summary of this one? Is that my
Summary
understanding?
of the how this fits in the rest of the bear group. He can send it to the chairs and I can refocus it if he doesn't want to send it directly to the IDR group. But one of the questions is how does this fit in the rest of the architecture? I've read the architecture document and I thought it fit in. I'd like to make sure that we check with the beer chairs and the beer working group to make sure we're aligned on this. Does that request make sense? If not, I can take that offline with you, Waymo.
Yeah, maybe take offline we can discuss in details and then about what architecture and then what details and then to what extent of the details and then I can summarize. Yes.
Yep. The whole idea is to have the IDR folks before we do the adoption call because it's coming up probably after the BGP AutoComp and the car DT one. It'll probably be one of the ones that comes immediately after. So we have a little bit of time. I'd like to make sure the working group has the context with a message that goes along with the call. So I just need to have your help there. Thank you very much, Waymo.
No problem. Okay, thank you.
Thank you. Can you hear me now?
Yes.
Super. I'd lost the connectivity. Next on the list to present is Link Bandwidth Extended Community by Wei Yan. Can you see the presentation?
Yes, we can.
Yes, we can.
Super. Thanks. When you there?
Yes.
Hello, we can't hear you. You're probably talking to a mute mic.
Well, we can actually hear his. Well, his face or his icon is flashing, so that means he's sending audio.
The audio is coming out very choppy at my end. Let's give him a minute. If it doesn't recover, we can go to the next presentation.
Oh, can you hear me?
Yes, much better.
Oh,
Please go ahead.
oh, oh, it's okay, it's okay. Now we start please. Hello everyone. My topic is the intention of link unwise in the community. This is the update for previous version. Um, next page, please. Reviews of the uh, 112 issues. First, the too many units definitions. We in this version we remove unit definitions. Use the original unit bytes per second. Second, a suggestion for decimal floating point type. We learning about the decimal floating point type and found that it was very complicated. Briefly, hello, is here.
Yes, we can hear you. Please continue.
Okay. I'll continue. Briefly, the decimal floating type provides two coding schemes, a decimal coding scheme and binary coding scheme. Those two coding schemes can be said to be completely different. Besides, the coding of the combined part is also difficult to understand. Thirdly, may use 64 bits unsigned integer. We think this is a feasible direction. Next page, please. At the same time, we also consider many extension methods based on the extended community attributes. First, the new coding scheme the same unit use the unsigned integer in byte per second. The bandwidth value range is limited. This is the problem. And second, the new coding scheme new units in megabit per second. This also has a problem that is the bandwidth value above can be fixed, but the traces was lost. Next page, please. So we extend the link bandwidth based on the 64 bits, a new type of IPv6 address specific extended communities attributes that is considered to represent in 64 bits link bandwidth. As shown in the picture, the type 3 or 3 are the commented refers to RFC 4360. Subtype is TBD. Next page. Thank you. More comments and discussion is welcome, and another ideas is also in welcome. Thank you.
Thank you so much. Any questions for Venian? Cool. Thank you.
Thank you.
The next presentation we have is about PGP metric credit from Shuffle.
Hi. Hello, can you hear me?
Yes, we can hear you. Please go ahead.
Okay, thank you. Thank you, Chair. Thank you all. Now I will introduce PGP metric credit path attribute. So next. Excuse me. How to turn the next page? Oh, thank you. So the motivation is that this topic is related with BGP intended rules. As I know, now the current BGP intended load scheme are discussed in IDR-WG. BGP intended loads include not only the load with minimum delay, but also with specific cumulative delay, for example, 100 milliseconds. So single intended template configured under intermediate BGP speaker may be used for multiple paths designated to different endpoints. That means that we cannot rely on the configuration on each BGP speaker to use different resolution delay requirements. So this information is better to cover in the advertised rules. Next, please. So these are typical scenarios for example. We can see the figure A from the head end to the end point, the intended load with delay 100 milliseconds. There may be multiple paths, but for each path, the segments may have different requirements. For example, in figure A, the segment from head end from A to B1 is 16 milliseconds, but from A to B2 maybe 40 milliseconds. That may be caused by the size of domain is different. Now we can see the figure B. That is similar. For example, the first pass is averaged by 50 milliseconds for each segment, but for the pass 2, it's 33 milliseconds per each second. Please, next. Okay. That is another two scenarios. We can look at the figure C. There are two intended loads designated to different endpoints, E1 and E2, but the intended identifier is same. The first intended load with delay 100 milliseconds, but the second is 200 milliseconds. So how does node B determine the different delay requirements for segment from B to E1 and from B to E2 respectively? And how does H determine the different delay requirements for the common segment from H to B for these two intended loads? So for the figure D, for this example, there's also two intended loads that designated to different endpoint with the same identifier, but both with delay 100 milliseconds. So the question is similar. Next, please. So at the current phase, we just provide the symbol schemes for symbol case. But this scheme has a premise that is intended routine is established between the known and determined endpoints with predictable propagation path controlled by policy. That is, the path is not arbitrary. For multiple propagation paths with very different hop counts, we suggest that using different intents or using the explicit propagation object list. The following metric correlated attribute information is just defined in the draft now. The metric correlated information is per target headend. For each headend, the total end-to-end metric correlated information and the estimated hop counts, and with the optional correlated piece information. This information can be applicable for the simple scenarios such as single path. For some complicated case, they maybe need the explicit propagation object that to be defined in the next version. So next, please. So based on the metric correlated information contained in the attribute, there is several methods to get the information for resolution. A simple method is using average metric correlated that can be get to the total and metric correlated divided by the estimated hop counts, and then get the average metric correlated with the relative metric to get the minimum value. And the second method is to use the explicit correlated piece. We can get from the correlated piece L with index. The index is just set by the current hop. Then we can get the minimum from the explicit piece and the relative value for resolution. The third method is using the EPO list data is to be defined in the next version. Next, please. Okay, that is the percentage of this document. Any questions and comments are welcome. Thank you.
Any questions for Shafu? Well, thank you, Shafu. And folks, that was our last presentation. We started 7 minutes late, and my apologies, but I believe we made it through the time. Jeff, Sue, any closing comments before we close the working group session? Sue, you have the mic.
Here, I've got the mic. My question is to any of the presenters, since we've ended up, thanks to CARE's good management, with a few bits of extra time. Does anyone want to raise any questions about any of the drafts? Just the last call. And while you're thinking, I'll let Jeff talk.
I'll just throw in closing remarks. Thank you, everyone, for coming to IDR and also dealing with our usual Friday session. It's been a very long week, and we're all quite tired. You'll note that there's a number of threads that have been started on IDR covering a wide variety of topics that have been raised during the sessions. And the chairs would like to urge you to go look for threads that are of interest to you. And also, if you see something that was a question you had that has not been started as a thread, please initiate one so that we can have good technical discussion. Thank you.
All right. With that, thank you all. We hope to see you in Philadelphia and more importantly in person. See you all in Philadelphia. And safe travels back home.
Okay, the ones that are out will close, but I think the chairs would like to talk a little bit about what we learned this week on the BGP AutoConf and the our CT talk. Thank you.